In this video, we will learn about inverse functions, linear, discrete. A function is one-to-one if no two different inputs into the function gives you the same output. In our example, we will talk about one-to-one functions g and h, and they are defined as g is equal to the set of -5, 3, -3, -5, 3, 9, and 4, 5. The equation h of x is equal to 3x minus 13. We will find a, b, and c in this problem. For a one-to-one function, there's a related inverse function written as f raised to the -1 power. So the outputs of f are the inputs of f raised to the -1 power and vice versa. Part A of our problem. Given the set of g, to get the inverse, we reverse the ordered pairs or interchange the x and y values. So we get the inverse of g is equal to 3, -5, -5, -3, 9, 3, and 5, 4. Next, we need to get the inverse of g at 3. To do that, we see that the x value is represented by 3. The corresponding ordered pair with that is -5. So y is equal to -5. That tells us that the inverse of g at 3 equals to -5. Part B of our problem, to get the inverse function of an equation, we will look at our equation h of x is equal to 3x minus 13. We will follow these steps. Step 1, replace the h of x with a y. So we get y is equal to 3x minus 13. Step 2, we're going to switch the y and the x. So we get x is equal to 3y minus 13. Step 3, we will solve for y. To do that, we'll add 13 to both sides to give us x plus 13 equals 3y. Then we'll divide 3 by both sides and get y is equal to x plus 13. Step 4, we replace y with the inverse of h at x. So we get the inverse of h at x is equal to x plus 13 divided by 3. Part C of our problem, we're going to find h of the inverse of h at 5. So we'll need to substitute 5 into the inverse equation. Remember, our inverse equation was h raised to the -1 of x is equal to x plus 13 over 3. So we substitute 5 where we have x. 5 plus 13 divided by 3 gives us 6. Now we substitute 6 into the h of x equation, which was our original equation. So that would give us 3 times 6 minus 13 is 18 minus 13, which gives us 5 for our final answer of part C.